Good evening everybody, and once again welcome to the video. This video we are going to solve a very tough problem from LeetCode. This question is essentially asked in Google interviews, that is trapping the rainwater. So let's take a look at the problem. This is very interesting. It took me a while to understand. Alright, let's get started. So the problem is something like this. We are given an array and we are asked essentially to output an integer which will tell you how much water can be trapped, right? So I'll try my best to explain you again, as I said, right? Let me see if I can draw it. Yeah, so here 0 represents that there is no height, 1 represents there's a 1 unit height, and similarly 0, then we have 2, so that is 2 units of height. So in between this and this block you can fill in water, right? That's 1 unit of water you can fill in. Again, as I said, I have a very nice explanation for this example on how to do it. So for example, I can fill in water here, right? I can also fill in 1 units of water here. I can fill in 1 units of water here, and then 1 unit of water here. So total is 4, right? So I can essentially fill 4 units of water here, right? That is the output, right? We are given an array and we have to compute this. So let's start thinking, man, how do I do this? So what we are essentially doing when we look at the problem, our brain is saying that, okay, here I have 1 unit, here I have essentially 2 units. So the difference of that 2 minus 1 is essentially 1 minus this length, that is 0. So 2 minus 1 is 1. That's one way to do it, right? Similarly, over here, right, how much I can fill? If you say we have 3 units here, to this side we have 1 unit. So 3 minus 1, that is 2. So this section I can fill in 2 units of water. Hopefully you got the idea, right? And now then I'll show you the code, okay? Similarly here, how much I can fill? So towards my right hand side there is 0. Towards my left hand side there is 2, right? So 2 minus 0, again 2, right? So 2 minus 0 is 2. Then we currently here we have 1 unit, right? So 2 minus 0 is 2 minus 1, that is 1 units of water I can fill. That is the algorithm. Now let's take a look at the example. So the way we want to solve it, and again, as I said, it took me a while to understand this, right? So what we need to do is essentially, when we are essentially going through an array, okay, and again I'll try my best to explain you. So we essentially store the max left in an array. So here we are saying, okay, what is the maximum to this element? 0. Okay, when you come to this element 1, right? Towards the left hand side of 1, what is the maximum you have seen? 0, right? Now I'm on the third position. So what is the maximum I have seen on the left hand side, right? So 1 and 0, what is the maximum? 1. Similarly here, what is the maximum I have seen on the left hand side? So there are 3 elements, 0, 1 and 0, right? The maximum is 1, right? And so on, right? So we populate the max left, then we populate the max min, okay? And we need to understand this very well, okay? So again we apply the same concept. What is the maximum I've seen on the right hand side? 0, right? So here comes 0. So 3 and 2, right? So after 3 aside, after 3 towards the right hand side, what is the maximum I've seen? Number 2. Move the window. Now what is the maximum I've seen? 3 and 2, right? So what is the max? 3, right? Similarly we populate this one right here, this essentially array. Now to essentially get the water essentially trapped at any particular block, what we need to do is, this is the formula, right? So now if you ask a question like, what is the water trapped at this level? So the answer becomes, the max is 3, the max left is 1. So what is the minimum of 3 and 1? It is 1 minus the current size, that is 0. 1 minus 0 is 1. So in this area I can fill 1 unit of water. Make sense? Okay, now we'll do the same thing again. How about we try this? What is the maximum here? 2 is 3. What is the minimum? It is 2. So minimum of 3 and 2 is 2. And what is the current length over here? 0. So 2 minus 0, that is 2. So the maximum water can be trapped in this section is 2. So as you can see, it's a very, very popular question, right? Now I tried to program the same thing, okay, and I'll explain you. So I create two arrays, left max and right max. If the length of the array is 1, then I return 0. Then over here I'm calculating my left max, not this one. So I'm calculating this guy right here, okay. So the way I do that is essentially I enumerate over the array. If it is the first index, I know I'm appending a 0, because always when you start at the first position, the maximum is always going to be 0, right? Then moving forward, I say left max dot append max of height colon idx. So what I do is essentially I strip the array. So what I did essentially, just to show you, so say I'm on the third position, right? So I strip the array. This is my array, right? And so if I'm on position 3, this one, right? If I'm on this position, my array would be this, right? And then I compute a max. What is max? 1, right? So now again I got this one. So now when I'm on this element again, the red one, my array becomes this. What is the maximum here? 1, right? That is exactly what this does. Left max dot append max, height is an array, and then I am slicing the array and then I'm taking the max out of it, right? I just explained you the concept here. Now the exact opposite goes here when we are doing the right max. So take a look at this for loop. Starts from length, goes to -1, and it decrements. So it goes in the reverse order, right? So now we are working on this guy, okay? This guy right here. So the first time it's gonna be 0. Whenever I'm on the first one, I haven't seen anything on the right hand side, so I append a 0. Same logic. Then here I have to use an insert and not an append, okay? So again, when I come here to this element, right? Let's say I'm on this element. So I ask myself a question. Towards the right hand side, what is the variables? I have seen 2, right? What is the max? 2. So I put 2 here, right? Now we move to here, right? My window becomes this, right? My array, right? So I ask myself a question again. What is the maximum sawmill here? 3 and 2, right? What is the max? 3, right? So 3, right? So I keep on propagating and I keep on populating my array here, right? I'm slicing the array. Remember, I'm slicing the array, right? So, and then I'm computing the max and I'm inserting into the array. And at the end, it's a piece of cake, right? Once you have both of this array, and all you need to do is just iterate over both the arrays. So I'm iterating over all the 3 arrays: height, left max, and right max, right? Which is 1, 2, and 3. And if you want water trapped at any level, so for example, water trapped over here would be what? 3 and 1, right? So what is the minimum? 1 minus the length of the current node, that is 0. 1 minus 0 is 1, so 1 unit of water, right? This is essentially what I programmed. I declared a global variable. I'm iterating over all the 3 arrays using a zip function in Python. Water trapped is equal to min of I and j, that is min of 1 and 3, right? Then I'm essentially doing minus c. C is essentially the current height of the node, right? So I get a water trapped, and I'm saying if the water trapped is greater than 0, if the value what I compute is greater than 0, add it to the sum value, and at the end return my sum. This is again a very tough problem. It is not easy. It sounds easy, right? But it is a tough problem, trust me. Myself, I had to go over this several times. Hopefully you guys can see. I had to write, there were several edge cases. I had to, figure this out. But finally I got this working, right? As you can see, I had to try this many times also, right? So I'll put the solution in the description section below. So check it out and pause the video and try to understand this problem. It's a very, very interesting problem. I really loved this problem. It's a great problem. So yeah, this was essentially problem number 42, which is asking Google trapping the rainwater. Thank you so much for watching. I'll see you guys in the next video.